Kat rumah, kat Keluang doktor.
Keluang Okay, orang Keluang semua sihat? Family semua sihat?
Sihat, Alhamdulillah.
Alhamdulillah. Dah breakfast dah semua? Ke belum? Aina dah makan ke belum?
Belum lagi.
Dah mandi ke belum? Aina?
Dah doktor dah.
Dah Oh, baguslah korang bangun awal. The good thing about e-learning ni, you can just wake up, mandi tidak, gosok gigi tidak, and then duduk tercegat depan komputer Alright, okay. Hazmi just got in. Sekejap tunggu Hazmi masuk. Hazmi? Hazmi? Oh, Hazmi.
Ya, doktor.
Awak dah cucuk belum?
19 hari bulan, doktor.
Oh, lambat lagi. Okay. So who else getting vaccination? Siapa lagi? Any one of you? Siapa yang sudah? Mimi sudah. Siapa lagi sudah? Siapa sudah? Senyap je korang ni. Okay, do me a favor. Sementara saya nak approve yang lain-lain ni, masuk ke YouTube. Masuk ke YouTube. Sekejap I'm gonna see berapa lama. Sekejap ya. I think it should be hari tu korang dah tengok nombor berapa 4 dan 5 Okay, 7 is what I have taught you on the RL circuit. So, I think it should be, hold on, let me just check. Which one is it? 5, 6, 4, 3, 2, Allahu Akbar. Ada ke 8 Kejap. Saya nak awak apa benda saya ni? Kejap ya. Can you see Laplace of integrals? Ada tak dalam list tu? Ada nampak tak Laplace of integrals? Can sekejap Sekejap tengok dekat mana list tu? Tweet Okay, thank you Akasha. Laplace 6. Okay, cuba tengok Laplace 6. Laplace 6 ialah sebanyak 5 minit. Have you guys watched or have you not watched yet? Tak apalah, tengok 5 minit dulu. 5 minit, we come back here 9 suku, sempat. So, I'm gonna write it here for those who just got in. So, watch Laplace. Laplace apa tadi? Integral 6 Was it 6? Please watch. Okay, thank you. Watch Laplace 6 on my YouTube. Come back at 9:30. 9:15. Ada sempatlah 9:15. Okay, do that now. Okay, I'm gonna mute myself. Korang tengok dulu ya. Come back at 9:15. How do I mute myself? Okay. Have you watched the video? Ada watch the video? Guys? Dah tengok Okay. Let's do this now. Okay. I'm just gonna recap what you have been taught all this while. Ada nampak tak saya punya slide ni? Okay. Right. How many of you in college, by the way? How many? Hazmi, Tan, Mimi, Anas Anas kat college ke kat rumah?
Kat college tu.
Okay, Anas. Siapa lagi? There's one more girl in college. What's her name? Forgot. Selain daripada Mimi ada lagi seorang kan hari tu? Siapa ya? Siti Noh. Nak panggil awak apa Hanim. Okay. So only five of you. Anybody else?
Saya doktor.
Siapa saya tu?
Izzat.
Izzat mana ni? Izzat Ganu, Izzat Farid. Oh, Izzat Farid. Okay. So 6 of you. Makanan cukup tak dekat college? Do you have enough food? Cukup. How do you get food during lockdown? Adalah dekat cafeteria tu. But you cannot go out kan? Oh, okay. If any of you have any difficulty financially, you can just PM belakang-belakang ya, PM saya. Alright? Okay, now, so coming back to this, so this is the table. I'm going to repeat again myself. This is the table. Always use the table. Always refer to the table. So we're going to refer to this table later on. So basically what you have learned is this. On the Laplace transform, I'm gonna let me just stop sharing here. So stop share. So what I have basically taught you before, let me just use the whiteboard. Senang saya conteng. Okay, so what we have done before is Laplace transform. Okay, so basically number one, mana saya punya ni? Okay, oops. Number one, you have your basically we always refer to table. Okay. So you know that if given an ft that goes into a Laplace process, a Laplace transform, we get Laplace fs. So in terms of writing the mathematical formula is that Laplace of ft is basically equivalent to fs. And what we have learned last Monday is basically on the derivative. So derivative which says that Laplace of, say, what if the f is differentiated at first level. So you get SFS. I'm going to highlight this is what? Spatial domain, capital, minus the initial value of the function at time 0. This is time domain. Okay, so those are two different functions at two different domain. All right. So a Laplace transform of f prime t, okay, is equivalent to s square fs minus s f prime 0. I've already shown you how to derive this. This is basically last week. I'm just going to recap and go fast here. So again, this is spatial. This two is at alamak, Imanuddin ni barulah terhegi-hegi nak masuk. Saya tak sempat nak approve dia. This is at time domain. Sekejap. Okay. So at time domain, whereby this is at the derivative, this is at the initial value. All right. Okay. So that is the Laplace of derivative. So we have done that. Basically, Laplace of derivative, I'm going to clear this. Now, what is the important for Laplace of derivative? Laplace of derivative is that, you know, sometimes when you have function like, you know, t square sine omega t, for example, in order to get this Laplace, when you cannot derive it directly, you can derive it via Laplace of derivative. So maksudnya, when you cannot derive Laplace transform directly from the table, okay? Kenapa tak boleh derive directly from the table? Because the table contains only basic Laplace transform. Okay, basic Laplace transform. So what do? You can basically then we solve via its derivative. Okay, via derivative. So we are done with this. Tips. All right. Okay, we are done with this. And the other most important part, okay, which I think you have to know is that the importance of this. I'm gonna clear this. Okay. Now, so especially with regards to circuits. Now, remember, yeah, coming back to whatever we are doing now, with regards to solving ODE. Meaning we are trying to solve, we are trying to get the function itself not in its derivative form. We're trying to get the function itself in an actual form. So in circuits, sometimes if you look at RLC or R, you know, it can be RL, RC, doesn't matter whichever circuits, this is circuits. You will get a lot of what do you call it, formula in terms of derivatives, and sometimes also in terms of integrals. All right, the formula itself can contain some derivatives, some integrals. Derivative of can be current. Integrals can be of the impedance. So it can be a combination of those. All right. And in such cases, if you want to solve the ODE, how do you solve the ODE for this? So remember, the derivative can be and integrals can be of many variables. Okay, katakanlah if RLC, your variables are resistance, impedance, capacitance, and of course you will have equivalent to voltage. Okay, it's always equivalent to voltage. RLC, voltage. If you have RL, you have resistance, impedance, voltage. If you have RC, you have resistance, capacitance, voltage. All right, so these are the many variables. It can be in terms of derivative, it can be in terms of integrals. So if you want to solve it, how do you solve? You solve it via Laplace transform. Remember, kalau kita cakap when we are talking about solve, let's say y prime prime, I want y. If y prime, I want y. In other words, you want the original function. So how do you solve via Laplace transform? First, you perform Laplace transform. Okay, macam hari tu our circuits, okay, we put in derivative function, etc. We get from IT, we derive the IS. But IS is this solving. When you get a Laplace function in IS, is this solving? We get this from a function we have I and also the IDT. Ini hari tu kita bagi contoh circuit RC lah contohnya. Now, when I got RIS, is it already solving? Because solving is basically kalau solving, if I want solving meaning I want IT, betul tak? Betul tak? Yeah, I have to call your names. One or Adlin? One?
Yes, Doktor.
Okay. Katakanlah saya dah solve belum? Kalau saya dapat IS, saya dah solve belum?
Belum.
Belum. Kalau nak solve, saya kena buat apa? Come on. Aimanuddin, if I want to solve it, what do I have to do? Contohnya, I have an RC circuit, yeah? I'm going to show you, okay. I have an RC circuit. Ada a function, within the function, ada I, ada DI/dt, ada resistor, ada capacitance, ada voltage, okay? This is our previous example, Aimanuddin. So, first I got the IS. Ada I, ada DI/dt, maksudnya ada Y prime prime lah, okay? If you can imagine, you have Y, you have Y prime prime. So, I, DI/dt, Y, Y prime prime. So, I got the IS, meaning I got the current, the Laplace transform of the current. Have I solved it? Aimanuddin? Kurang ni. Izzat, Parit, have I solved it?
Yes, Doktor.
Adakah saya telah solve?
No.
No, kalau saya nak solve, saya buat apa?
Do a Laplace transform.
I've already transformed, okay. Saya dah transform semua and I try to solve it with the DI/dt. I try to get only IS. I try to equate the function in terms of IS, meaning I've already got the Laplace transform. So, lepas saya dapat Laplace transform, what do I do?
Integrate.
No? What is the reverse process of Laplace transform? What is the reverse process of Laplace transform? I'm going to go and show you the circuit, yeah. Let me just show you the circuit. Kita dah show case study hari tu. Okay, where do we do? Okay, this is the circuit. Now coming back here. Now, tengok balik sini, ya. Have a look here, have a look, because this will come out either in your test or your exam. If you look here, this is I, meaning I in the time domain. This is I prime t. Alright? So when you do Laplace here and here, then by the end of the day, what we did last Monday, we tried to equate everything in terms of IS. Okay, whatever the function. So is this already solving it? No, it is not. In order to solve it, you have to inverse. So inverse Laplace of IS, you will get IT. Alright? Imagine if, okay, this is contoh circuit yang simple, alright? In actual application, you have very complicated circuits, alright? You have so many resistance, you have so many capacitance, you have integral, you have derivatives, of the current or whatsoever. You have resistance, you can have, you can have parallel circuit, series circuits, very complicated circuits, and you have a lot of resistance, impedance, capacitance, voltage sources. So you have they are a function of complicated what do you call it, if you want to solve it, there are the complicated functions in terms in the actual form, or its derivative, or its integral. All right. So you will see actual whatever the function in its actual form too, if you can imagine y. Its derivative is y prime. Is the integral is the integral of the y prime. So in order to solve it in a complex circuit environment, so most often we don't solve it directly like what we do with our ODE or PDE, you know, because if you want to solve it that way, you have to like macam awak buat dalam what do you call it, electrical circuit analysis. You have to gather semua. You have to basically solve the function first. Okay. So let's say you don't want to solve the function. You have the equation for the whole circuit. No matter how complicated, you have the equation of it. Okay, because solving may requires you a lot of headache, etc. So the easiest way in circuit analysis, this is where students of what do you call it, electrical engineering, your electrical engineering counterparts students, what they do in order to solve it, they don't solve like in mathematically. It doesn't make sense. What they do, they transform everything into a Laplace transform. Okay, so when they solve it into a Laplace, then they can solve it easier in the Laplace transform. But again, let's say if they're trying to solve the current, they get IS. It is not yet solving. In order to solve it, you have to inverse back to the time domain. Then only you have already solved it. You get what I'm trying to say? Okay. So if I give you a circuit, I can give you a circuit like this. I can ask you, solve the current via Laplace transform. So what do you have to do? First, you have to transform everything. It's easier for you to solve it in the Laplace domain, and then only you inverse back to the time domain. So that is why that is the use of Laplace transform basically in electrical circuit and also in mechanical. So can you imagine a mechanical parts? You take your clock, for example, or a machine that is a moving machine. All these mechanical parts, they have so many variables, and some are in integral form, some are in its derivative form. So in order to solve it, the easiest way is Laplace transform everything, because it's easier to solve it in Laplace transform, and then once you solve it in the Laplace transform domain, you revert back to the time domain. All right. So that is basically the actual application of Laplace transform in today's world. Okay, let me just go back to the slide. Yeah. Okay. So basically, so this is what we've done before. So here, when we have this I, okay. Kejap ya. So here, when we have this I, suddenly everything is lagging. Alamak. Mana? Oh, it's not detecting. Kejap ya. Okay, when we have this I, okay, here I basically have the IS. I have the current, but the current is in spatial domain. So remember, kalau solving, we always want to get the actual function, but we want it in the time domain. So to solve, I input IS. Okay. I inverse Laplace it, and I will get the IT. So sometimes you may see this in your test. If you don't see it in your test, you will see it in your final exam. You will get something like this. I ask you just to solve the circuit. Do it in the Laplace transform domain. All right? Are we clear? Is that Farid? Clear tak clear?
Yes.
Family kat rumah sihat ke?
Sihat.
Okay. Mana tadi? Siapa tadi? Apa benda? Apa nama tadi? Apa tadi?
Warna Adlin.
Faham tak faham?
Faham tak ke?
Faham. Alright. Okay. Now, okay. So we are done with derivative. Now I'm going to go into integrals. Ayo. Okay. This is integrals. All right. Integrals. So integrals is as simple as this. Integrals is saying that if I have an integral from 0 to tau of any function ft, okay, so this is in integral form. If I were to Laplace this whole thing, this is equivalent to 1 over s fs. So if you ask me what is fs, fs is basically the Laplace transform of the function itself, okay? Function itself, the Laplace transform is fs. But in the integral of the function is 1 over s fs. So basically now, okay, you have learned, clear all drawings sekejap ya. So basically now, okay, ini yang saya kata the challenge would be for you is basically what you have learned is basically you have learned first shifting theory, that says Laplace of EAT multiplied with FT is basically Fs minus A. And then you have also learned Laplace of derivative, which says Laplace of F prime T is basically S Fs minus F0. And you have also learned Laplace of integral, that says Laplace of the integral of 0 to tau ft dt is basically 1 over s fs. Now don't worry so much, yeah. The formula of this, the table of this, I will basically give it to you. I probably give it to you in your WhatsApp, so because it's open book anyway. But I will give you one table where you can refer all these formulas, where you don't have to, go through one module to another. You can just got it from the table, all right? But the challenge to you is basically to identify when to use which. Kalaulah if for example is in a time domain, if I ask you to Laplace transform, it's easy. So this is shifting theory, this is Laplace derivative. Kalau ada bentuk integral, this is integral. It's easy for you to select which formula. But what if it is in Fs domain, you want to invert back to Ft, you want to get the inverse Laplace transform, then you have to really crack your head. Tengok betul-betul. Does it looks like Laplace of integrals or Laplace of derivative or Laplace of shifting theory? That is the challenge for student to decide which formula to use. Okay. Now, what was my example? Okay, my example was my example was the example that I've given you just now is basically, I'm gonna use a different color. Let's try black. Is I given, okay, Fs is basically 1 over S square plus omega square. Now, tengok balik table. Go and look at your table. The basic table. Can somebody post the basic table please? In the WhatsApp. Kalau dalam basic table, what do you see? This shape. What do you see from the table? From the table, which is the nearest? I want to know, basically, the question asks, what is Ft? Okay, now from the table, what is the nearest format? Sorry? Look at the table. Which pair? Which pair from the table? Let me call Haziq, Kajang.
Yes, sir.
Which one from the table is nearest to this? Which pair?
The first one should be 1 over S.
Okay. Kalau Ft equivalent to 1 over S, Fs is?
S is kalau FT sebab yang ni dia integral, sebab saya 1. Macam terbalik tu. Kalau FT is
Ni apa Ft? T 1 over S. Okay, what about this? What about this?
Kalau yang tu
Cos omega T.
Okay.
cos
What is the
omega
closest?
T.
What is the closest? What is the closest shape?
FT cos omega
Cos
T.
omega T.
Kalau cos omega T, what is here?
S over S squared plus omega squared.
Now, do you see S there? Ada S tak?
Tak ada.
Tak ada. Sebab remember S is a variable ya. So kalau tak ada S, apa yang awak boleh buat kalau tak ada S? Pilih bentuk lain.
The third T tu 1 over S square.
Hold on. Let's just look at S square plus omega square dahulu. 1 over S, forget it first. S square plus omega square dulu. Which one? Okay, you cannot use cos omega T because you don't have S. Betul tak? Okay, what else? What formula can you use? Okay, remember I've told you, if it is addition, positive, negative, yes. Multiplication, no. Remember I've told you? Okay. Last Monday. Okay, now, never mind the S. Tutup mata dulu the S. Tutup mata dulu 1 over S tu. 1 over S square plus omega square. What is the closest you can get? Haziq Izzuddin, section 4. Mana dia?
Ada tu.
Okay, apa khabar orang section 4?
Alhamdulillah sihat.
Family sihat?
Sihat Alhamdulillah.
Okay, now tell me which one.
Saya pun ingat yang paling dekat tadi cos omega T.
Tapi tak ada S kan? We don't have S. Kita tak ada S di atas. Kita ada S kat bawah. So macam mana? How?
Kalau EAT?
Ayyo. Jauhnya. Firas.
Jauh juga
Section 3. Cepat. Section 3.
Sin betul.
Jangan kasih malu
Sin omega
orang
T.
bagi.
Sin omega T.
Sin omega T. Sin omega T apa kat atas?
Omega.
W kat atas doktor.
Mana ada W? Apa benda tu omega?
Omega.
Omega.
Okay.
Salah.
Okay, kita ada omega tak kat sini?
Tak ada.
Tak ada.
Tak ada. So kita dah buat macam mana?
Multiply
How do
1
we do?
over omega.
Omega.
1 over omega because omega is a constant. S is a variable. Omega is a constant. So you can put this, you can put the Fs as 1 over omega multiply with 1 over S multiply with omega over S square plus omega square. Boleh tak? Because this one can cancel out each other, you will still get 1. Betul tak? Wang Yinan. Wang Yinan, are you here? Wang Yinan? Is he here? No? Wang Yinan, do you understand how I did it? Tabina,
Yes.
do you understand?
Yes.
Alright, okay. Because sometimes I tend to... Okay. What did he say? Did he say he understand? Okay. Okay, never mind. Because sometimes, alamak, where do I go? Alamak. Kejap. Okay. Because sometimes I tend to explain in Malay. So if you don't understand, stop me. Yeah. Tabina, I think you're familiar with Malay. Wang Yinan, you have to stop me. Okay, notify me. Okay, if you look here, why do I choose sine? Because what do you call it? Omega is basically a constant. So it's easier if I put constant here. I can also put SS here, but you know when you have more variables, you will have headache. How do you solve S? Okay, this itself is already a headache. You understand? Okay, so you put a constant 1 over here. So you know for this, it will be what? It will be sine omega t. Okay, okay, fine. So in other words, if let me just clear this again. Clear all the drawing. This is where I think you have to look at your formula, diagnose it, bring out, bring out, try to expand it, find how you can basically do it. Again, I come back here. S square plus omega square. From the table, we can conclude 1 over S. I'm taking 1 over S out, this one out. Since I want to use sine, so 1 over omega multiply omega over S square plus omega square. So you diagnose it, take it out, all right? So you know this is basically a constant. Okay? And you know this, the inverse of it is basically sine omega t. Alamak, korang ni keluar masuk, jenuh lah saya. Okay. Now, and if you look into here, this is where I told you, because this is multiplication, you cannot do 1 over S and then multiply. No, it doesn't work like that. If multiplication cannot. So if you look into what you have learned, it is basically Laplace transform of integrals. Remember, Laplace transform of integral says Laplace of integral 0 to tau ft is basically 1 over S Fs. Okay, so this implies integral. So how do we solve this? Therefore, ft, tengok ya how I write, is basically, because it is integral, so I'm going to put integral 0 to tau ft. What is my ft? sine omega t, okay? But don't forget you have a constant here. So I'm going to bring the constant here, 1 over omega. Do you understand? Haziq Izzuddin. Do you understand?
Yes, Doktor.
Haziq Rafi Kajang. Do you understand?
Faham tak tu?
Okay, boleh faham ya? Okay. So now I'm gonna do this. So 1 over omega. What is the integration of sine?
Negative cos omega t.
Omega.
Negative cos
Omega.
omega t. Ada omega kan? So if it's integration, multiply or division?
Division.
Division by
over
what?
Omega.
Over omega, okay. And it varies from 0 to tau. Alright. So 1 over omega. Substitute tau here. Tau is actually a variable, okay, but it's a constant of a variable. Meaning kalau awak kata macam limit tu, dia it's not like until infinity, but it's a value. The value is tau. It can be any value, alright. So if you substitute tau inside here, negative cos omega tau plus cos 0 over, okay, because this is omega, I'm going to take it out, omega square here. Okay, so if I solve this, what is cos 0?
1.
Firas? Okay, this is 1. So 1 over omega square 1 minus cos omega tau. So we leave it that way. Okay. So in other words, I'm going to clear, I'm going to erase some part here. Hold on, yeah. Let me try to erase this slowly. So in other words, if you do this, I'm going to write it here. Sabar ya. Slowly, I rub this out. Oh, by the way, our RT for the COVID is basically 1.07. The last I checked. So it's almost there. Hang on tight, yeah? We'll get through this. As long as everybody is well behaved. Alright, where were I? Okay. Alright, okay. So, tadi what was the answer tadi? FT is basically 1 over omega square 1 minus cos omega tau. Am I right? Okay, this is the answer from this. Now, assuming if I have here s square, how do you do? If I have here s square, this is equivalent to, if you were to take out, is equivalent to 1 over, sorry. Let me just undo this. It is basically 1 over s times 1 over s times 1 over s square plus omega square. Am I not right? Yeah? Am I not right? Fahim, section 5. Am I not right?
Yes.
Fahim, do you understand? Alright, okay. So basically, tadi we have solved this, isn't it, Fahim? We have solved this part where we got this. Am I right?
Yes, Doctor.
Okay, so now for this FT, for the new FT, if I have square, what do I do? If there is 1 over s here.
Become 1.
Huh? Apa dia Fahim? Hayo. Fatin Shahalam. What What do I do, Fatin? Safwat, Kajang. I need that keluar. Safwat, apa dia? What do you want to say?
Tak ada apa. Saya tak lagi.
Cecilia, where are you, Cecilia? Are you in Pontian?
Kat rumah.
Family sihat?
Alhamdulillah.
Okay, cepat Cecilia.
Oh, yang ni Part ni saya tak sempat habiskan video tadi. Tapi saya tak faham yang ni. Macam mana doktor buat?
Okay. Tak apa. Tashri, Seremban. Come on, Seremban. Come on, Seremban boleh. Come on, Seremban. Ayah. Nilai mesti boleh. The favorite place, Nilai. Nuri. Come on, Nuri. Why suddenly there's...
Doktor tanya apa tak ada.
Ayo. Awak tidur.
Internet connection. Teruk.
Saya bagi saya ambil air dulu. Alamak, aduh. Saya kata kalau ada 1/s, darat 1/s, or how do you solve? Muni, berenang. Kamu berenang. Berenang.
Ya,
Family sihat?
sihat. Alhamdulillah.
Okay, so macam mana kita nak solve? Bila tekuk saya dah nak pukul 10 dah ni. Come on. Okay. Apa theorem of integral? Laplace of integral is equivalent to what? 1/s fs. Okay, so if you see 1/s is integral, so in other words, in this case, is double integral. So tadi just now this one, this part we have solved just now where we got this. So now we add another 1/s, meaning another integral, but you don't have to start from the very scratch, you just take this. So you just take this, integral of 1/omega square 1 minus cos omega tau. You get this, okay? So if you get this, okay, 1/omega square, you take it out. So 1/omega square, what is the integration of of 1? Safwat. Integration of 1.
Tahu.
Huh?
T.
T. Okay. Integration of cos.
Negative sign omega t over omega.
Okay, thank you. Okay, and then vary from what? 0 to tau. Okay. So substitute. You substitute here. So masuk sini tau. So 1/omega square tau multiply sin omega tau over omega. Kalau 0, when you substitute 0 is 0. Sin 0 is also 0. So you are left with this. So can you see how we got this? No, okay. I know it's over 10. I just want to clear up this part. Give me one pair. If t is equivalent to exponential at, What is the Laplace of it? Fs is equivalent to what? Tengok dalam table. Quickly, cepat. Am I talking?
1 over S tolak
S.
E.
Over S minus A.
S minus A. Alright. Now, if I have E80 over S, what if Fs?
Integrate.
Integrate 0 to tau.
1 over SA. S minus.
Sorry. So this is okay. Sorry, this is this. So if I have HS is equivalent to 1 over S minus A. So you can safely say this is integration. Tadi E80 E80, so integration 0 to tau E to the power of 80 is as simple as that. If I have GS 1 over S square S minus A, so you can easily say it is 0 to tau double integration, okay? E to the power of 80 dt. This part, do you understand? I'm gonna go again. Amina Rawang, do you understand?
Yes, Doctor.
Faham eh? Okay? Okay, faham eh? We don't have much time. We're gonna stop here. Next week, I'm gonna start with another module. Okay, hold on. I'm gonna do this. Stop sharing. Now, okay, so we have done this. My suggestion to you. Sekejap eh. Kalau sempat, we cover this. Kita cover je lah. Otherwise, you won't know. Okay. Somebody please screenshot this. Screenshot this and put it in the WhatsApp. Anybody done it? Screenshot this, put it in the WhatsApp. Try this. I'm gonna call one by one in random on Monday to solve this. Okay, you better know this. If you don't know this, nanti test awak kelabah. Remember I told you, it's straightforward. If it is alright. Dekat. Okay. I'm telling you, if it is function, you want to Laplace transform, you can easily go into the table and pick up which one to do. Fine. But if it is inverse Laplace, okay, like here, the second part here, you really have to think hard. Which formula I'm going to have to use? Okay. Later, next Monday, I will give you another formula. So that is the challenge for all of you. All right. Okay. So do this, please do this, please do the exercises. Otherwise, you know, when you're familiar with the exercises, you're basically practicing yourself to know which formula you're going to use. Do it. If you don't do it, you will have trouble in your test. You will have your trouble in your final exam, and I won't help you. All right. Okay. That's it for today. Thank you very much. Assalamualaikum. I'll see you guys Monday. All right. Please do it. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Waalaikumsalam. Thank you, Doctor.
Terima kasih.
Thank you, Doctor.
Terima kasih.
Thank you, Doctor.
Okay, thank you.